Oh hi YouTube, Thunderblade in the area! So, you really like the idea of Electric Inline Skate, but you couldn't find anyone. So you decided to build your own. So you are in lucky, my boy. Right now I'm going to show you all about the Thundrblade prototype, which parts used and how to build them. So let's go. Okay, this is the 2022 Thundrblade prototype. It uses 4 motors, 2 on each foot. Okay, it uses just one remote control. It controls all 4 wheels at the same time. It has regen brake, which means when you brake, it recharges your batteries. So how do I build it? And how can you build your own? First, I'm going to explain all the parts used and then how to actually where to buy them and how to put them together, and of course how to build your own. So let's start by talking about the motor. These motors are hub motors, which means the motor is inside the wheel. You see this red thing here is the metal plate of the motor, and you have this really wide tire. It has a 105 millimeter diameter and a 60 millimeter thickness or width. So you have one on the back, one at the front. This uses a hoverboard battery. So if you have 1 or 2 hoverboards sitting around, you can actually get their batteries to use on this. This is a 36 volt setup. This prototype also has 2 ESCs, 2 electronic speed controllers, 1 on each foot, and each electronic speed controller controls 2 motors, up to 2 motors. You can put them to use with 1 motor on each foot, or you can even use just 1 single motor to drive you. Of course, 4 motors is more powerful, 2 motors less, and 1 motor only, it's the weakest. I'm going to disassemble the prototype right now and show you all the parts used. So let's take a look at the remote control first. Okay, this remote control has a display right here. It shows you battery status on battery 1 and battery 2. Okay, it shows you the speed, although of course this speed is not completely accurate. I don't know if you can see right here. It shows you the mode. Right now it's on Pro mode. You can click here and you change it to 1, medium, high, and Pro. On the low setting here, the speed is limited to 6 kilometers an hour. On the medium setting, the speed is limited to 16 kilometers an hour. On the high setting, the speed is limited to 31 kilometers an hour. And of course, the Pro is no limits. Here you can control the throttle. You use here to accelerate forward. You can see. And you go backwards to brake. You can see here the brake. This brake is a regen brake, which means when you brake, it actually uses your speed to put energy back into the battery. You can see right here, you can see this is AWB mode, all-wheel drive mode, which means it's controlling all 4 wheels at the same time. And here you have the power button. So this ESC, it controls both motors, right? But one other good thing it has is this. Right here, the power button. Okay, it comes with a power button, so it turns off, and when you press it once, you make a beeping and it's on. Okay, so no messing around with the cable, with the battery cable, and it's off. So why is the battery cable here, not inside, all tucked in? Right, so let's talk about the electronics. Here you can see these are the motor cables. It comes from both motors. You can see right here, it comes from the side of the motor, so it's kind of hard to not have it around here, around the outside. You know, because these motors are actually meant for skateboards. So it makes sense from a skateboard point of view, but if I ever get these motors to manufacture for Thundrblade, I will definitely make the wires come on the right angle here instead of up, so it's easier to tuck them. Okay, so let's keep talking about this. So here is the battery. This is a XT60 connector, which is really easy to find. Here you have the batteries and the electronics are tucked inside. So I'm going to take off the motors now to show you the insides. So just a regular Skate 2. And I need to take off the battery case right now. You see, the first plan was to actually screw. I have the screw hole here. This is a 3D printed box, but this right here, you should have a screw going right through here. You even have the, but in the last time, I just ditched that idea because of the vibration here was so intense that I welded a metal bar here to support this weight. So right now it's actually taped, right? Because this is just a proof of concept, right? So this is taped right here and right here. So I'm going to take off the tape. So the battery should slide right off. Okay. So right. Okay. So this is the battery right here. It's glued to the inside with a lot of tape. So tape is a friend, guys. It actually doesn't fall, you see? So it's nice. So let's take off the last tape here, and it should, okay, right now. Okay. So here's the battery. You can see here it's a generic brand, never heard of it, don't know who makes it. It's lithium ion, right? It's 10 cells, 2 parallel, which means there are 20 batteries inside here to make up for a 36 volt battery with 158 watt hour. Okay, so it's 36 volts, 4,400 milliamp hour. You see this is the real power of the battery. Smartphones and whatnot, they use the milliamps, but the milliamps means nothing without the voltage. So this is 36 volts times 4.4 amp hour, which give us the 158 watt hour. So this is with what we use to get the range estimation. Anyway, so this is the battery. You have the XT60 connector. Really cheap, really affordable, really easy to buy. And now let's talk about the electronics right here. You have the motor cables coming through here. Okay, here you have the electronic box, the ESC, right? It's actually really well glued with a double-sided tape to the frame, so I actually can't take it off right now without breaking the actual box. So I'm going to just make the video right here. So let's take off this motor right here. You can see I just put it and it slides right up. Here are the wires. And you can see there are lots of colored wires here. These ones I'm not using right now because the ESC doesn't have the support for this. And we actually don't need the Hall sensors. These are the Hall sensor wires. It makes the motor move rolls better, but they are not necessary. So these are the wires. So you can just disconnect them right here. Easy, just really easy. You have colors here, you have colors here, so it's really easy to match them, but it doesn't actually, you can actually put them in any order. It will not burn the motor or the electronics, it will not fry anything, okay? You can put in any order. The only thing that actually makes a difference here is if you put them on and you get the remote and you accelerate it, and then the motor is turning backwards. If the motor is turning backwards, you just get here and change 2 colors, just 2 colors. You change 2 colors and it's done. So every time you put the motors in, you put these on, you have to test it before you close, so you know the motors are spinning the right way. So you have these right here. So let me show you the connectors. Okay. So the same thing here. From this side, just unplug them and it's ready to get out. Okay, now I have the 2 motors off. You can see the ESC. This is the ESC, the electronic boards inside this. It actually has metal plate to help with heat dissipation. Although I think a good fan around here would be better for longevity of this part. And you can see this wire right here. This wire goes to the power button, which is taped right here. It goes like this inside here. So now you can take a look at the frame without the motors. You can see the nicest weld you ever seen. I'm joking, this looks like crap, okay, but it works. Okay, so how does the motor is connected here? Just on this side is just a normal nut here. So the thing is right here. You have a square profile that goes into the motor, like right here. So if you don't have this square profile, the motor will not have anywhere to actually like sit, okay? So it will spin like whoo. So you need this to have the power to transmit to the frame so the wheels can go forward. Every time you put a hub motor, you need somewhere to lock it to the frame, and this is it. So how do I do it? I actually got 1 nut like this. Then I drilled through it, welded it to the axle, and then with a grinder, I ground the hex to a square. And this is what you get. A square profile. This is not really hard to do if you have the proper tools, but you can do it by hand with a file and release and some nice elbow grease. Okay, it will take a while to do it on hand, but it's doable. Okay, next up is the boot. How do I attach the boot to the frame? You see here, you just get the normal, oh yeah, now is a good time to talk about it. I repurposed this, okay? This was not meant to be a frame. I just had the sheet, the folded sheet laying around, so I just use it. And because the motor is too wide and I wanted to get the boot screw right in the middle, I had to actually weld a piece of metal here so I can put the bolt right here. So it's just a normal bolt. So just grab your skate tool. Just take it out like this. So that's why it's universal. But since the frame it's straight, it's a straight line here. Since the frame is straight here, and all the normal inline skates they have a heel up here, I needed a spacer. So this is a 10 millimeters or 1 centimeter drop or heel height. So this one is actually 3D printed. It's just a one centimeter printed plastic part. It actually holds. I've been using this part since 2015 actually. So it holds, it lasts a while. But the bolt needs to be longer. Okay, so I had to put a normal screw here instead of a normal Allen skate bolt. Right? You can see this is very, very long to actually reach. So, normal dupe boot. This is actually a power slide Nordic boot, but it's the same as the dupe. You can see right here in detail, this is the original bolt, and this is the one I had to use. They are, yeah, this is way longer. So this is the frame. You can see the perfect welding job I made here. Okay, I was in a hurry, sorry, I didn't grind it down, I didn't need to. But the next one I will make a better welding job, or I'll just pay someone to weld it perfectly. You can see here the reinforcement I need to make for the frame because it's a one-sided frame, okay? And it just doesn't hold. This doesn't work without a really hard steel, which I don't have. This is just normal carbon steel. It's not strong enough for this. So next time I build a frame, I will build a double-sided frame more traditional way, like this. So when you have your frame, if it's double-sided or not, or single-sided like this, you need your axle. You need the part to actually, for the motor to sit in and to transfer torque to the frame, okay? This can be made several ways. The way I made is like this, okay? And the axle is welded. If it's double-sided, you can't weld your axle. Next time, I will make this like this. So, this is it. This is Thunderblade 2022 prototype with double hub motors. So yeah, again, thank you very much for everyone that supported me on Ko-fi. Otherwise, I couldn't have bought these parts and made this and continue with the channel. So if you find it interesting and you like the videos and you want to keep watching about the development of Thunderblade, please consider making a donation. The link to the Ko-fi page is right here on the screen and on the description below. You can have access to our Discord server by becoming a member. Okay, if you go to the Ko-fi page and become a member, you have access to our Discord channel, so you can talk directly to me anytime. I will make a new prototype and keep making videos about this and making tutorials. So what you guys want to watch next, please leave a comment below. Did I leave some information out? Do you have any more questions about this prototype? Just leave them below. I'll try to answer them all. And if they're good questions, I'll make a video about it to explain it in detail. Thank you very much, and let's storm the streets.